Okay, guys, this is exam 3, question number 3. Let n be a positive integer. Prove the statement using mathematical induction. We have 1/2 plus 1/6 plus dot 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 plus 1 over n times n plus 1 is equal to n over n plus 1. So the only thing I'm going to do here is I'm just going to do a quick aside, and I'm just going to rewrite this running total in summation format. Right, so that's k equals 1 to n of 1 over n times n plus 1 is equal to n over n plus 1. Okay, so our first thing that we do is we find our base case. And this is just setting n equal to 1, which is the lowest value that k can be. So this is the summation from k equals 1 to 1. I messed up that. I messed up the summation here. This is not supposed to be n, it's supposed to be k. Sorry, guys. There we go. Okay. So that's 1 over k times k plus 1. And so that's just equal to, we're just going to put 1 in for k. We're only doing one iteration. So that's 1 over 1 times 1 plus 1, which is equal to 1/2. Now I'm going to do the right side. So setting n equal to 1, that's 1 over 1 plus 1, which is equal to 1/2. And of course, 1/2 is equal to 1/2. So we're done with our base case. Now we do our induction hypothesis. This is setting n equal to L. So that's the summation from k equals 1 to L of 1 over k times k plus 1 is equal to 1 over L times L plus 1. No, I'm sorry, I did something wrong there. It's n over n plus 1. Sorry about that. So that's L over L plus 1. Okay, so now we do our induction step. This is setting n equal to L plus 1. So I'm just going to take the same summation that we have. I know that's going from 1 to L. So that's the summation from k equals 1 to L of 1 over k times k plus 1. Now I'm going to add one more iteration for the L plus 1. That's 1 over L plus 1 times L plus 2. And that's equal to putting L plus 1 for L here. So that's L plus 1 over L plus 2. My right-hand side is as simplified as I'm going to get, so I'll just leave that alone. What's important to note here is the reason why I use the summation notation is because this is equal to this. So I can just replace it with this. So I'm left with L over L plus 1 plus 1 over L plus 1, L plus 2 is equal to, and I'll do double quotes there. Okay, so we need a common divisor for these two fractions. The common divisor looks like L plus 1 times L plus 2. So I have to multiply top and bottom by L plus 2 here. So that's L plus 2 over L plus 1, L plus 2, plus 1 over L plus 1, L plus 2. Double quotes again. So the top is L times L plus 2 plus 1 all over L plus 1, L plus 2. I'm going to distribute this L, so that's L squared plus 2L plus 1, all over L plus 1, L plus 2. This factors into L plus 1 times L plus 1. I can take out one of the L plus 1s. So that's equal to L plus 1 over L plus 2, which is what we wanted on the right-hand side. Right? They're the same. So I'll just write it one more time, just to make it very clear what I've done. And we're done, QED.